Today on How It's Made. Hospital laundry. Brass instrument restoration. Excavation buckets. Hospitals generate a lot of dirty laundry, from patient gowns and sheets to cleaning rags. Some facilities do the washing in-house, but to free up hospital space, some send theirs out to industrial-sized laundry operations that deal in high volume with bigger and better equipment. The hospital sends all fabric items to the laundry, including bed linens, towels, patient gowns, bibs, and cleaning rags. The only exception is surgical linens, which are usually disposable. The laundry company picks up the order and delivers it to the plant. Next, workers unload the bags of soiled laundry on large rolling carts. They weigh each one for internal statistical purposes and scan its barcode to track the laundry for each hospital. Workers handling the bags wear gloves at all times. The bags are plastic, which is more suitable than cloth for containing liquid, odor, and bacteria. Workers rip each one open and, without touching the contents, dump them on the conveyor. They discard the bag in a suction device that sends it to a baling system. The bales of bags go to a recycling facility that turns them into garbage bags and other polyethylene products. From this point on, everything is automated. The conveyor drops the soiled laundry into a sturdy cloth bag. Once the bag reaches 120 pounds, the conveyor automatically stops loading. The filled bag travels to an overhead conveyor system, which leads to one of several stainless steel, tunnel-shaped washing machines. Inside, a large rotating screw pushes the load through 2 pre-soaks, then moves on to 6 chemical wash cycles designed to remove tough stains such as blood and iodine. Next are 5 treatment cycles to soften the fabric and normalize the pH level. Then 3 rinses. The load of now clean laundry exits the tunnel washer and enters a hydraulic press. The press applies around 12 tons of weight to squeeze out the residual water. The load comes out compressed into what they call a cake. A conveyor transfers it to an elevator, which transports it to the drying area. The conveyor puts 2 cakes at a time into the dryer. An infrared sensor inside signals the dryer to stop when the load is dry. About 22 minutes later, a revolving paddle called a cake breaker separates the stuck-together items to prepare them for sorting. From this point on, automation ends, and manual sorting begins. Workers pull different categories of items and toss them into designated linen hoppers that are hooked up to scales. When a bag hits the target weight, it automatically drops down onto a conveyor, which leads to the final processing area. Here, items are either folded or bulk packaged in plastic bags. Workers load the bulk items into a vacuum system, which feeds into automated bagging machines. The machines have either a built-in scale which weighs the bag as it fills, or a photo cell which counts the items dropping into the bag. Once the bag reaches the target weight or count, the machine heat seals and releases it. Certain items have to be folded. Luckily, a machine automatically folds bed pads, bath towels, and patient gowns by flipping over the ends with short blasts of air. The neatly folded items collect underneath the machine, then travel by conveyor to the shipping preparation area. Here, workers stack them onto rolling carts. A different folding machine handles the larger items such as bed sheets and flannel blankets. A worker clamps an item to the feeder. Then the machine, using rollers and straps, processes the item until it's neatly folded. The clean laundry goes back onto carts, into the truck, and back to the hospital. Life on the concert circuit can be punishing, not just for the musicians, but also their instruments. Dents, scuffs, and general wear can ruin the tone of a brass instrument. But with a professional restoration, a badly damaged horn can once again shine in the spotlight. They may look ready for the scrap heap. But incredibly, these not so gently used brass instruments can be salvaged. Technicians will use a combination of techniques to make them look and sound like new. The restoration work starts with this solid steel ball. The technician inserts it in the bore of the saxophone, just under some deep dents. He places a plastic sheet on the dents from the outside. It protects the finish from scratches as he now moves a powerful magnet over the dents. The magnet pulls the ball against the inside of the instrument with such force that it pushes out the dents. After 30 seconds of this magnetic manipulation, the dents are completely gone. Using a series of engraving tools, another member of the team restores the artwork on the instrument. He follows the traces that remain and recreates designs that have completely worn away. He only has one chance to get this right. This takes skill and a steady hand. The next technician reattaches a key cup to the hinge rod and melts solder into the joint to make the connection permanent. The brass looks very tarnished, so he buffs the key cup and rod to a mirror finish. He now attaches the restored key and rod to the saxophone and screws it into position. He presses the end of the key lever to confirm that it moves as it should. He now inserts a fluorescent light into the body of the saxophone. It will help him find air leaks. But first, he activates an adhesive with a torch and applies it to the back of a leather pad. He pries an old and deteriorated pad out of one of the key cups. He transfers the new glue-back pad to the key cup. He closes the key against the tone hole, and the escaping light indicates a leak. So he heats the pad to reactivate the adhesive and shifts it a bit in the key cup. Now, the key completely closes the tone hole when pressed. The next thing to be repaired is a key guard foot that's broken away from the horn. This is delicate work. To resolder it, the technician uses a hydrogen gas torch because its flame is more precise. At another station, a new part takes shape. They carve a brass cylinder to transform it into a new spring barrel for a trumpet valve. He inserts the spring barrel into the top of the piston, and the fit is good. He then places all the trumpet valve parts in a water and solvent solution. He switches on an ultrasonic device, which sends high-frequency sound waves through the solution. Microscopic bubbles bombard the parts and remove oil and grease. The trumpet now chills in a cryogenic freezer at -301 degrees Fahrenheit to relieve it of residual stresses. Back to room temperature, the technician inserts a tiny camera into the bore of the horn. It gives him an inside look at the alignment of the piston ports as he presses the valves. As with any instrument, the proof is in the playing. This sax is sure to meet the approval of crowds of music lovers. Displaying a life-size replica of a horse makes a galloping statement at a farm, a racetrack, or a Western-themed venue. Some horse owners even commission a replica in the likeness of their favorite animal. A life-size fiberglass horse can be an attraction. But before this replica, there was an artist's sculpture in either wood, plaster, or styrofoam. The sculpture served as the model to produce this three-part mold to cast one or more replicas. They apply a release agent so the casting won't stick to the mold. Then they partially brush on and partially spray a 0.4 millimeter thick layer of gel coat. Gel coat is an easy-to-repair resin-based material that produces a smooth, shiny finish on fiberglass. 3 hours later, the gel coat is dry. Next, they apply 2 layers of resin-saturated fiberglass fabric in the hard-to-access area of the mold. Then they roll the fiberglass flat against the mold to prevent air bubbles, which would cause defects. With a tool called a chopper gun, they shoot shredded fiberglass mixed with resin over all the other gel-coated areas of the mold. They roll out the air bubbles and pack down the fiberglass to a consistent thickness of 3 millimeters. This ensures the hollow horse will be strong enough to withstand up to 400 pounds of people sitting on it. The resin-filled fiberglass cures within approximately 2 hours. Then they drive in wooden wedges to pry the casting from the mold, just enough to grab hold of the edge and pull. Thanks to the release agent they applied earlier, extraction is effortless and causes no damage to the casting or mold. Nonetheless, they carefully inspect the surface to be sure it's free of defects. Next, they pass a grinder along the perimeter to trim off all the excess fiberglass and smooth the edge. Each part of the mold produces half a horse, so the next step is to join the halves into a whole. The attachment must be hidden on the inside so it doesn't show. They first temporarily attach the halves on the outside with galvanized steel brackets and straps around the legs. Then they cut a large opening toward the front of the horse to be able to access the inside. They first fill the small space between the two halves with putty that auto body repair shops use on cars. Then they reinforce the joint with a double layer. Then they close up the openings. They temporarily hold the cutouts in position with galvanized steel brackets and fill all around with putty. The putty and inside strips dry in an hour, at which point all the brackets can come off. Now they work on the outside, sealing the space between the parts with more putty. Once it dries, they flatten the seam with an electric sander. Then they remove marks left by the sander by manually using a very fine sandpaper. The seams are now flush with the rest of the surface. Once painted, they won't show at all. After cleaning the entire horse with acetone, they spray a coat of primer over the puttied seams. Then, with fine sandpaper, they prep the surface to receive automotive paint. The horse is ready to be painted. With delicate strokes of an airbrush, an artist gradually paints the animal to life. Before finishing her artwork, she'll apply 2 coats of transparent varnish to protect the paint from precipitation and the fading effect of the sun's rays. Excavation buckets are groundbreaking tools. Attached to the bottom arm of backhoes or other heavy equipment, they scoop up tons of soil and rock to make holes in the ground. For jobs like building foundations and laying water and sewer pipes, excavation buckets dig right in. For soil excavation, there's quite a bucket list. Manufacturers make excavation buckets in a range of sizes and profiles. They can have teeth or a smooth blade, depending on the kind of soil they'll be digging. They custom design each excavation bucket on a computer and map out the dimensions. The computer then guides a plasma torch as it cuts parts from high-strength steel. Here, the torch produces attachment plates for holding the bucket to the excavator arms. It even cuts the holes for the pins that will hinge it to a boom arm. Each part weighs over 200 pounds. A powerful magnet lifts it over to a metal pallet to await refining. Next, the computer-guided torch carves through a thinner sheet of steel to produce a template. Parts of the excavation bucket will be shaped in this template, so they'll match up when assembled. With an oxygen fuel torch, they bevel the blade to give it the edge it needs to bite into the ground. This blade profile is for sandy soil. A jagged edge is preferred for rocky or clay terrain. Next, it's over to a powerful press. It bends another part into an arch. This arched part will straddle the top of the excavation bucket. Meanwhile, at another station, a press bears down on the beveled blade to shape it to the template. The template is a cardboard copy of the steel one cut earlier. The operator confirms that the first bend is angled correctly. He then sprinkles lubricant and aims the press a few centimeters away from the first bend. It takes 6 to 8 hits to achieve the desired 90-degree angle. Once satisfied, he'll bend the other end to the same degree. Using rollers, the factory transforms a flat piece of steel into the bottom and back wall of the bucket. The operator checks the curvature of the part with each pass until it's spot on. They're now ready to pull all the pieces of the excavation bucket together. Using chains and a hydraulic system, they pull the sides up to meet the back wall. The steel template is now put to use. It's positioned on the front lower lip and serves as a guide as the chains bend the sides. With the sides now flush to the back, a welder first tacks them together and then does permanent welds. He guides the blade into position at the front of the bucket and welds it to it. When this weld is complete, he'll remove the steel template. The attachment plates have by now been linked by thick pins. They lower it onto the top of the bucket, and it fits snugly to the arch and to the back wall. He welds the attachment assembly to the bucket. They paint the bucket inside and out. Yellow or black are popular choices for excavation buckets. Clients usually match the color of the bucket to the machine that moves it. It takes about 50 hours to manufacture an excavation bucket, and then it's ready to hit the ground. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.